Hey everyone, welcome back. So today we will be solving second order differential equations with Laplace transform. So without further ado, let's go to our first example. Hey everyone, so today this is our first example of solving second order differential equations using Laplace transform. And as we can see here, it's a non-homogeneous one because it's not equal to zero. And we have some initial value conditions at the start of the problem. Okay, so our very first step when we try to solve second order differential equations using Laplace transform, we must take Laplace, the Laplace transform of the right-hand side and the left-hand side of the equation. So doing that for the left-hand side of the equation, we have here a Laplace of y double prime minus 4y is equals to taking the Laplace transform of the y double prime gives us s squared ys minus s times y of 0 minus y prime of 0 minus 4 times taking the Laplace transforms of y alone, we have sys minus y of 0. All right, from here on, we can simplify because we can put in all the initial value conditions here at the start of the problem there. So y of 0 is equals to 0, so we can cancel this term, we can cancel this term, and we can cancel that term. Therefore, this equation or this Laplace transform simplifies to s squared y of s minus 4 times s y of s. Okay, so we're done with taking Laplace transform of the left-hand side of the equation. Now let's take the Laplace transform of the right-hand side of the equation. Doing so, we have Laplace transform of at e to the t plus 2e to the t. All right, taking the Laplace transform of the first one, at e to the t is just 8 over s minus 1 squared. And if you guys do not know what step to do here, this is basically just using the Laplace tables, or you can go back and check out the previous video where we discuss about taking Laplace transform from the table and also taking the inverse Laplace transforms. So taking the Laplace transform of 2e to the t is just 2 over s minus 1. Now, we have taken both the Laplace transform of the right-hand side and the left-hand side of the equation. Now we equate them to each other. So we have s squared y of s minus 4s y of s equals to 8 over s minus 1 squared plus 2 over s minus 1. Now from this step, on the left-hand side of the equation, we want to factor out our y of s. Okay, so let's factor that out. Therefore, we have here s squared minus 4s equals to 8 over s minus 1 squared plus 2 over s minus 1. Now we want to set this into a y of s equals equation. Therefore, we need to divide both sides by s squared minus 4 of s. So we have y of s here. This is equals to 8 over s minus 1. Actually, let's make this better because we're going to have a big fraction right here. 8 over s minus 1 squared times s squared minus 4 of s plus 2 over s minus 1 without the square times s squared minus 4 of s. All right, we are at this equation right now. Now we want to simplify or we want to combine the fractions together. And how do we do that? So we know that the denominator, we're just off by the s minus 1. Therefore, multiplying the second one here by the second fraction here by s minus 1, we have s minus 1 squared, s squared minus 4 times s. And on the numerator, we have 8 plus 2 times s minus 1. Okay, let's simplify this a little bit because this looks terrible for us right now to take the partial fraction decomposition, because whenever we have a fraction and on the denominator it's factorable, therefore that is our cue to do the partial fraction decomposition. Okay, to do that, we have 8 plus 2s minus 2 on the numerator. Let's keep the denominator the same here. S minus 1 squared, s squared minus 4 of s. Therefore, this simplifies to 6 plus 2s. And take a look at the denominator here. We have s and s here, so we can factor out the s. Therefore, we have s minus 1 squared, and s minus 4. Okay, we have simplified the fraction into the simplest form, and we've combined the terms, and we've got the common denominator. Now, what we're gonna do, as you all may guess, and what I've mentioned previously, we're gonna do the partial fraction decomposition. Okay, so now ys is equals to 2s plus 6, which is what we have there, and then s minus 1 squared, s minus 4, taking the partial fraction of this one, so we have a over s. That's the first one. The second one, we have b over s minus 4. Our third term will be c over s minus 1, and our last term, which is d, is going to be s minus 1 squared. Now, after this, we need to cross multiply everything. Therefore, let's switch the left-hand side equation to the right-hand side of the equation, and let's switch the right-hand side to the left-hand side of the equation. Okay, doing so, we will have a times s minus 4 times s minus 1 times s minus 1 squared. Bear with me, this is going to be a very long one. And then we have plus b. Actually, this is just s minus 1 squared, not s minus 1 and s minus 1 squared. So we have that one there. B times s minus 1 squared plus c times s minus 4 times s minus 1 plus d times s minus 4. And everything here is equal to 2s plus 6 as the numerator of the left-hand side of the equation originally, right here. All right. Now, if we expand this, if we expand all of our quadratics here, s minus 1 squared, that's just s squared minus 2s plus 1. And then we expand this, which is the same as this one. And then we need to multiply s squared minus 2s plus 1 with s minus 4. So if you expand all of this, what you will be getting is a s cubed minus 6a s squared plus 9 times a times s minus 4a plus b s cubed minus 2b s squared plus bs plus c s cubed minus 5 times c times s squared plus 4 times c times s plus d times s squared minus 4ds, and everything here is equals to 2s plus 6. Okay, this is a very long one. But now, after we have it in this form, we can group all of the terms that have an s cubed, that have an s squared, that have an s to the power of 1, and also who are just constants without the s variable. Okay. To do that, let's do it one by one actually here. That's s cubed, that is s cubed, that is s cubed, and we don't have any more of the s cubed, so a plus b plus c is equal to 0. Because right here on the right-hand side of the equation, we do not have an s cubed. Therefore, the coefficient of an s cubed is just 0 s cubed, okay? That's where we get the 0. Now, let's group all of our s squared. Okay, doing so, we have here negative 6a s squared, negative 2b s squared, negative 5c s squared, and ds squared. So doing so, we have negative 6a minus 2b minus 5c plus d, and everything here is equal to 0 because on the right-hand side of the equation, here again, we have 0 s cubed. Sorry, 0 s squared, not cubed. Now, let's group all of our terms that have s to the power of 1. Okay. Doing so, we have here 9as plus bs plus 4cs minus 4ds. Right? 9a plus b plus 4c minus 4d. Now, everything here is equals to the coefficient of our s to the power of 1, which is 2. in this case. Now for our next part, we will group all of our terms that doesn't have an s, or they're just constants in this case, right? Because they don't have any variables. And in this case, we only have one here, -4a, and we have 6 there, okay? So doing so, we have -4 times a equals to +6. Now, what we want to do, like what we always do when we solve for partial fraction decompositions, we want to find all of our a, b, c, d terms, okay? So in this case, our a is very obvious on our last equation here. So we have -4 times a equals to 6, dividing both sides by -4. So we have -6/4, which also simplifies to -3/2. I'm skipping a little bit of steps here when we're simplifying the fractions or any decimal numbers or rational numbers. So we do have enough space to show you guys the whole process, okay? So now we have a equals to -3/2. Let's keep that. Let's box that out so we don't forget about it. Now our next step is, since we have a, our equation is going to be much easier. So because we can put in our a's here, let's use this equation right here, both of the equations, okay? Let's use it right there. So we have the a equals to -3/2. So plugging in into the first equation here, we have -6 times -3/2. That cancels a negative, okay? That gives us 3, so that's going to be 9, okay? So we have 9 here, minus 2b, minus 5c, plus d equals to 0. And our second equation here, when we plug in a equals to -3/2, let's simplify that actually. So 9 times -3/2. Therefore, we have -27/2. Okay? -27/2. So in this case, we have here -27/2 plus b plus 4c minus 4d equals to 2. All right. This looks like a messy equation, but we can simplify both of this equation, this one here that we just used, down below here, okay? So now we have -2b minus 5c plus d equals to -9. Let's move the 9 to the right-hand side there, okay? And for our second equation right here, let's simplify that. So adding both sides by 27/2. So let's do it here, 2 plus 27/2. So we know that this is just 4/2 plus 27/2. That gives us 31/2. Okay, so we have b plus 4c minus 4d equals to 31/2. Okay, all right, we have both of these equations set up. However, we do have three unknowns here. If we do have three unknowns and if we have only two equations, it's going to be hard most of the time to solve it. But we can definitely solve this. How can we solve this? Well, take a look at our first equation right here. So we have a plus b plus c equals to 0, right? Therefore, if we plug in the a, we have b plus c equals to -3/2. +3/2 because we add both sides by 3/2, right? Therefore, let's set this into a b equals equation. So we have b equals to 3/2 minus c. Now, we have this here, b equals to 3/2 minus c. Let's substitute our b into each of this equation. Therefore, if we substitute our b there, we only have c's and d's. And when we have two equations to solve and we have two unknowns, we can use either substitution or we can use elimination. We'll use elimination, okay? So right here, we have -2 times 3/2 minus c minus 5c plus d equals to -9. And then for the second one, we have b, which is just 3/2 minus c plus 4c minus 4d equals to 31/2. All right, let's simplify both of these equations right here. There's a lot of simplification process here because we're dealing with three unknowns and actually three unknowns, and we have four equations here. However, our fourth equation is already giving us one of the unknowns, which is very good, okay? So Right here, we do FOIL, we'll multiply it inside, we'll expand it out. So that cancels that. So we just have -3 minus C plus C actually, plus 2C minus 5C plus D equals to 9, -9. And then for our second equation here, let's simplify this, okay? So -C plus 4C is just positive 3C minus 4D equals to 31/2. Let's simplify this more actually, okay? Let's do it. Let's do it on the right hand side here, so we're not getting confused of it. Put some arrows here because we're doing the simplification here. We're simplifying. So adding for the first equation right here, right? We want to add both sides by 3, so we cancel out the 3 on the left hand side. And we want to simplify our 2C minus 5C there. So we have here -3C plus D equals to -6. Second equation there, we add both sides by 3/2. So we have 3C minus 4D equals to 34/2, which is also equivalent to 14, right? 34 divided by 2. Okay, now we have that, actually now 14, 17. Now we have all of that. What we're going to do is let's do the elimination here, okay? So when we do elimination, it's very obvious right here because we can cancel out the C's here if we do addition on our elimination. So we can cancel out the C's. Now we have -3D equals to -6 minus plus 17, or 17 minus 6 is just 11. So our D is just -11/3. We got D, we got A. Now let's try to solve for our B and our C, right? To solve for that now, since we have our A and our D, we can use either of the equations or both of these equations right here on the start of the problem, right? So doing that, let's plug in our values for D and A for this equation right here, the second equation here in our system of equations that we begin with. So -6 times -3/2 minus 2 times B, which is just B here because we do not have the B yet, minus 5C plus -11/3 equals to 0. And then our second equation here, we have 9 times A. Our A here is just -3/2 again, right? And then we have minus plus actually, plus B plus 4C minus 4D. And our D is just -4 times -11/3 equals to 0. All right, we have both of these equations. All of you might guess that, oh, let's do elimination again. We can do elimination, substitution, everything. That will take longer. Why? Let me show you here. At the start of the problem, we have set B equals to 3/2 and minus C, right? So we actually do not need the second equation right here. Why? Because we can substitute this B and only have C's. Therefore, we can solve the C. And then doing that, right? So let's cancel out the negatives here. Let's simplify this. That's going to be 3. So we have 9 minus 2 times B. B is just 3/2 minus C from this equation right here, right? Remember at the start of it? So we have that minus 5 times C minus 11/3 equals to 0. All right, let's simplify this equation more. So we can cross that, right? Therefore, we have 9 minus 3 plus 2C, because the second one here, we're going to cancel out 2's, plus minus 5C minus 11/3 equals to 0. Therefore, we can simplify the C's here. We have -3C. We can simplify this. 9 minus 3 is 6. And then 6 minus 11/3. So let's do that. 6 minus 11/3. Let's find the common denominator. Let's set this into 3. So 3 times 6 is 18. Therefore, 18 minus 11 is 15/3. Right? That's 15/3 equals to 0. And then now we want to move the 3C to the other hand side. So we have a positive there. So we have 3C equals to 15/3. And then we divide both sides by 3. Therefore, our C now is equals to 15/9. We have A, we have D, we have C. We just need B. b. Now, what is b? Take a look at the green one here at the start of the problem here, where we set b equals to 3 over 2 minus c. We can use that, right? B is equal to 3 over 2 minus c, which is 15 over 9. Okay, let's make the common denominator again. That's 18. So that's going to be 27, right? This is still going to be 15. Therefore, we have 12 over 18, and this simplifies to b is equals to divided by 6. So we have 2 over 3. There you go. We have A, we have B, we have C, we have D. Now let's sub in all of our terms, our A, B, C, D here into our partial fraction that we started with, okay? So let's copy this down right there, actually. Let's take this down now. Let's take all of this down to below here so we can see what we started with of our partial fraction that we compose. Now we have A is equals to negative 3 over 2, so that's just going to be negative 3 over 2 over S, plus B here is 2 over 3, so 2 over 3 over S minus 4. C here is 15 over 9 over S minus 1. D here is just negative 11 over 3 over S minus 1 squared. Our very last step, after we did all of this, we just need to take the inverse Laplace transform, okay? So taking the inverse Laplace transform of what we have here, all of this one here, our partial fraction, right? So taking the inverse Laplace of all of this by using the Laplace tables, okay? We're not gonna do it from scratch. So using the Laplace tables, so take all of the inverses here, we have our final solution as y of s equals to negative 3 over 2 plus 2 over 3 e to the 4th t plus 15 over 9 e to the t minus 11 over 3 times t times e to the t. There you go. So this is how we will solve for second order differential equations using the Laplace transform. It's a very long list here, so I'm gonna zoom out so you guys can see everything.